Okay guys, so I'm going to take you through the free response section of the AP exam, okay? The free response section was revised in 2011. Okay, there were changes made, mainly that instead of being 3 calculator questions and 3 non-calculator questions, there's only 2 calculator questions and 4 non-calculator questions. So you might want to pause and read over each screen before I start talking about things. So you can pause me anytime, read over, and come back to me when you're ready. But we have, okay, so what you're going to see is what you're going to actually see on the cover of your free response section when you get your AP exam, but I'm hoping that you do not take any time on the day of the actual exam to read it, because that's why we're going through it now, so you know what you're supposed to be doing and what you can and cannot do and still earn points. Okay, these are the actual instructions that you will see at the top of your test, okay? So I would like for you to pause the video and actually read these instructions. Okay, when you're done reading, come back to me. Okay, so you guys are going to be getting 3 pieces of paper for the free response section, or 3 packets of paper. Okay, you have part A, it's a green insert, part B is a blue insert, part A is the calculator questions, part B is the non-calculator questions, and then you're going to be putting all your answers in the pink booklet. All your answers go in the pink booklet. No credit will be given for the work in the inserts. Okay. It says to write clearly and legibly and to cross out any errors you make. Okay. They tell you that erased or crossed out work will not be scored. We're going to talk a little bit more about that. But they just tell you don't bother wasting time erasing. Okay, so part A, you get 30 minutes for 2 questions, and you're only allowed to work on the questions in part A. You're allowed to use your calculator, okay? Okay, there's 4 things that you're allowed to do with your calculator. You can find the derivative of a function at a point. You can calculate the value of a definite integral. Okay, you can solve an equation, and you can graph, all right? Anything else you shouldn't be doing on your calculator. During the time portion for Part B, you may keep the green insert and continue to work on questions in Part A without the use of a calculator. So after the first 30 minutes are up, you're able to work on all 6 questions, but you may not take your calculator back out. Okay. The other last thing that they say that's really important that you notice, it says it is not expected that everyone will be able to complete all parts of all questions. There's 2 factors here. There's the time factor and there's the this is a tough test factor. Okay, so don't get to feeling overwhelmed. Just tackle the things that you can tackle, and if you don't know how to do part A, but you need an answer for part A to get to part B, just do something. Get an answer, take a derivative, take an integral, do something for part A, and then work through it, okay? And the readers who are grading your test will take into account what you did in part A and work through your numbers to give you whatever points that you're eligible for in the later parts of the question. Okay, let's go through some specifics. Okay, and again, I would just pause and read over everything before we keep going. But the first thing that they say is that if you want the reader to ignore some kind of work, they say crossing it out is not only faster, but also a clearer indicator than erasing. And you can use a pencil or ink. Okay, so that was that first one. If you have 2 different solutions for the same question, okay, let's just talk about crossing out work for a second. If you have nothing to replace it with, don't cross out your work, don't erase it, okay? Better to have something. You might get 1 point out of 3 maybe, but that 1 point might make the difference between a 3 and a 4 or a 4 and a 5. So don't, unless you have something better to replace it with, don't cross out your work and do not erase your work. If you work through the problem and then you go back and you work through the problem again and you're like, oh, which one's better? I would suggest crossing one of them out, have a good instinct. If you keep both sets of solutions, what they will do is they will score both sets of solutions, average them, and then round down, okay? So I think you're better off just picking one. All right. Okay, the next thing they say is to show all your work, okay, which is why we were such sticklers about this all semester. Clearly label. Your work will be scored on correctness and completeness of your methods as well as your answers. Answers without supporting work you will usually not receive credit. Okay, so if you're supposed to set up an integral and then integrate it on your calculator and all you do is write down the number, chances are you're not even going to get the answer point. You're going to get nothing. okay? Justifications require that you give mathematical reasons, not the calculator says, or the graph goes from positive to negative. You need to be specific. It needs to be a calculus explanation. So the derivative changes from positive to negative, that kind of thing. All right. And then they, again, emphasize showing all your work. It's important throughout Section 2 of the exams. If there's not work, there's not credit. All right. Next one, in questions where two or more functions are under discussion, for example, a function and one or more of its derivatives, you cannot make ambiguous references, okay? That's why in class all semester I said it is a dirty word, okay? Readers will not infer a specific reference when there is more than one possibility. So you're not going to say it goes from increasing to decreasing. You're going to say the function goes from increasing to decreasing. You're not going to say it goes from positive to negative. You're going to say the derivative goes from positive to negative, etc. Okay? All right, let's keep going. Go ahead and pause me. Come back when you're ready. All right. Again, they're talking about show and work. So if you have a correct final answer, no supporting work, generally you're not going to get points for it. Okay. And then if you have an incorrect answer and no supporting work, there's no partial credit for them to give you. So sometimes if you have an answer without work, you might get an answer point, but usually if there's absolutely no work, you're not going to even get the answer point. So you need to show all your work. Okay, in the second and third comment, they talk about justifications. Okay, so you read through what they said. Again, you can't say that I see that the graph goes through those points. You need to give a calculus explanation, a math explanation. Showing work and justifying an answer are pretty much the same thing. Work justifies an answer, but there are times that there's a verbal explanation to be had, and that's when they usually say justify. Okay, but again, there's a major emphasis on the process that you take, which is why our focus has been there all semester long. And they keep at it. They keep talking about justification, okay? It requires a mathematical argument to support the claim or conclusion, where you can cite a theorem, a property, or a test. And when you're citing those theorems, properties, or tests, you don't need to call them by name. You just need to explain the goods. So intermediate, you don't have to say by the intermediate value theorem. You just need to say, because my function is continuous, I need to take on every value between the values at the endpoints. Okay, so you never need to mention any theorem by name or the second derivative test by name. You just need to say, hey, I have a horizontal tangent on a function that's concave down, and if I have a horizontal tangent on a function that's concave down, I have a local maximum. Okay, so I'm utilizing the second derivative test without ever calling it by name. All right, the next thing is sign charts. Okay, sign charts, hopefully all semester long, you guys got it through your heads that you cannot just have a sign chart without a verbal justification with it. AP used to take sign charts, and then everybody's sign charts look different. Okay, some people had a derivative on top and a function on bottom. Some people had the function on top and the derivative on bottom. Some people were using marking their zeros and their places where their critical points and where the derivative wasn't existing. Some people were not. Some people were using a single plus. Some were using lots of pluses. Some people were partially labeling. Some people were completely labeling. And they finally said, enough. Okay, they love sign charts. Okay, they say that they're a useful tool to investigate and summarize. I love sign charts. You love sign charts. Everybody loves sign charts, but they are not by themselves, will not be accepted as a sufficient response when a question asks for justification for the existence of either a local or absolute extrema. Okay, there's a whole packet on the sign chart justifications, but you need to verbalize the sign chart. So you see on the sign chart that f prime is changing from positive to negative, and then underneath it you say at x equals 3, f prime changes from positive to negative, and therefore I have a local maximum. Okay, so make sure you are verbalizing your sign charts. Okay, moving on, they keep talking about this, so pause, read this over. I feel like this first section is pretty self-explanatory. Just that's fine. You need to show your work, give an explanation, think about why they're asking for it, etc. And they talk about it again down here, Okay, so there's a lot of emphasis in your test on showing your work and giving justifications. Okay, and they give some examples here. And they talk in both of these sections, this one and this one, about an absolute extrema versus a local extrema. And just remember that a sign chart type explanation is okay for finding absolute extrema if there is only one single critical point. If there is more than one critical point, then you need to consider the values of both critical points and endpoints for finding absolute extrema. Moving along. Pause and come back to me when you're ready. Okay, but again, it says to show the computations or work that leads to your answer is just another phrase that they use to remind you that you need to show how your numerical result was obtained. So again, the reason why we focused on showing all your work all semester long, that you have to show your setups, you need to show AP where you're coming from, where your numbers are coming from, what your thought process is. The work is extremely important. Let's move on. Okay, let's talk about what you can do with your calculator without showing computational steps. So go ahead, pause it and read it and come back to me when you're ready. Okay, on part A, which are the first two free response questions, you are going to be using one of our graphing calculators or possibly your own. There are 4 things you can do without any justification or explanation or I did this on my calculator or anything like that. You can graph a function. You can solve an equation, okay? And there's 2 ways that we can solve our equation on our calculator, but I hope what you're doing is graphing and finding either points of intersection or zeros on your graph. All right, that's how you should be solving equations. I know some of you guys are using the TI-89s, and on the 89s there is a solve feature. Please do not use that solve feature when you've got when you've got trig involved, okay, because you get those funny, bizarre answers. But you should be solving your equations by graphing and either finding points of intersection or finding zeros. Next, you can compute the value of a derivative at a point, okay? So that means I can find f prime of 4 or g prime of 2. For those of you guys using the 89s, you should not be finding derivatives without them being at a point. And then the final thing is to calculate the value of a definite integral, okay? And those are 4 things that you guys can just write your setup. So for example, I can write f of x equals 4 at x equals 2, let's just say. And I don't have to show any intermediate steps. I can write that the integral from 1 to 5 of g of x is 7/2, let's say, without any intermediate steps if it's on the calculator section. Okay. They talk about some of the extra things that you should be able to still be doing. If they ask you to graph, you should still be labeling the function, the axis, and a scale. Okay. Stating the equation that was solved, that's just like what I did here. Stating the function and the point which its numerical derivative was calculated. So for example, writing that f prime of, -1 equals 16. I don't know, I'm picking random numbers. So that's stating the function and the point at which the numerical derivative was calculated. Okay, that's that. And then the last thing is stating the definite integral that has been calculated. That's just what I did here. Okay. And actually, they emphasize what I said to you guys. So when you're solving equations, you should be using the intersection or the zero feature, finding zeros on the graph. You should avoid use of tracing along the graph, okay? Because when you trace along your graph on your graphing calculator, it looks at pixels. It does not look at values of the functions. So you cannot trust the trace feature. And they say that the graphical approach to solving equations should be used before using the solver commands, okay? They're much more reliable. They're much more accurate. Let's move along. All right, I am out of time, but I have 2 more slides to get through, so I am going to make a part 2 to this video and get through those next 2 slides with you guys. So please see free response instructions part 2.